41 light-years from here, there is a planet that scientists once believed was made of diamond. Not covered in diamond, made of it. A world with a crust of solid carbon, crushed by unimaginable pressure into gemstone. That story made headlines around the world. It was beautiful, it was irresistible, and it was wrong. 55 Cancri orbits a sun-like star in the constellation Cancer. Close enough that we can study it in extraordinary detail. It's a super-Earth. About 8 times the mass of our planet, but only twice its width. Which means it's dense. Shockingly dense. And it is close to its star. Terrifyingly close. 1 full year on 55 Cancri takes less than 18 hours. Its star would fill a huge portion of its sky, baking one side into a permanent inferno. This is not a place. This is a furnace with a surface. Back in 2012, astronomers made a startling calculation. They measured the ratio of carbon to oxygen in the host star and found something unusual. Extra carbon, a lot of it. If a planet forms from a carbon-rich disk of dust and gas, it might not build a mantle of silicate rock like Earth's. It might build a mantle of pure carbon. And under the crushing pressure deep inside a planet, carbon doesn't stay soft. It crystallizes, layer after layer, compressed into graphite and diamond. By one estimate, up to a third of this planet's mass could have been crystallized carbon. A diamond world orbiting a distant sun. It was one of the most captivating ideas in modern astronomy. But an idea is not proof, and more data was coming. In 2024, the James Webb Space Telescope turned its infrared eye toward 55 Cancri E. And the crust of the diamond myth began to crack. Webb didn't see a hard, gem-crusted shell. It saw heat, immense, shifting, restless heat, consistent with something else entirely. A planet-wide ocean of molten rock. Not a diamond crust, a magma ocean, hundreds of kilometers deep, glowing at temperatures over 2,000 degrees Celsius. And from that ocean, gas was escaping. Carbon monoxide, carbon dioxide, bubbling up from the melted interior, venting into space, and forming something no one expected. An atmosphere, a secondary atmosphere, exhaled by the planet itself. Not inherited from its birth, not stripped away by its star, regenerated, again and again and again. Every hour, this world is remaking its own sky, out of its own melting flesh. That is not a gemstone. That is something rare. A living, breathing furnace. Here's how astronomers pieced this together. Webb's near-infrared camera and mid-infrared instruments measured the planet's thermal glow across a dozen infrared wavelengths. A bare rock would radiate heat one way. A thick atmosphere would radiate it differently. The signature Webb found pointed away from bare rock and toward a real, if strange, atmosphere. But this planet refuses to sit still. Its brightness at certain wavelengths has been measured to shift by a factor of 3 in less than a week. Scientists are still debating exactly why. Shifting clouds of silicate, bursts of volcanic outgassing, an atmosphere that thins and thickens and thins again. The honest answer is, we don't fully know yet. And that uncertainty is exactly what makes this planet worth watching. Why does any of this matter? Because 55 Cancri E may be showing us something no telescope could ever show us about our own world. Earth was once a magma ocean too. Billions of years ago, before continents, before oceans of water, our planet glowed like this one glows now. We can't travel back in time to watch that happen. But 55 light-years away, a planet is living through that stage right now, in real time, for us to study. The diamond myth first got people to fall in love with this planet. The truth is turning out to be even stranger. A world remaking its own atmosphere, one breath of gas at a time. We used to think this was the diamond planet. It might be something better. A window into how every rocky world, including our own, begins. If you want to keep exploring worlds like this one with me, hit subscribe and ring the bell so you don't miss the next one. What should we explore next? Let me know in the comments. Until then, keep looking up.